Hello, Gen Chem friends. I hope you're doing well today. Welcome to Chapter 10, which covers the third state of matter that we discuss in this course, which is on gases. So on the left-hand side of the screen have the three different states of matter that we will talk about in this course. All of these are pictures of water, the same substance, solid, liquid, or gas. And looking at a cartoon of those gaseous water molecules, you see their composition is the same as in solids or liquid water, but the molecules have a lot more space between them. They've got a lot more freedom of movement. And because of that, gases can easily expand to fill their containers. They're easily compressible. It's very easy to compress a gas. It's very hard. If you try to compress a solid, you got to use more force. And because of the space in between the molecules of a gas, they have very low densities and they can more easily form homogeneous mixtures. So those are some properties of gases that distinguish them from solids and liquids that you need to be familiar with. One way that we characterize or describe gases is in terms of the pressure that they exhibit within their container. There are two ways that we can measure pressure. The first is through a traditional barometer. So the Torricelli barometer that was discovered in the 1700s. Essentially, it used mercury and the atmospheric pressure of mercury to determine what the pressure of the atmosphere was at a particular time of day. And so the pressure that was exhibited by the atmosphere was measured via a column of mercury. And so it was because mercury was used that pressure was initially reported in units of millimeters of mercury, mmHg. Now, eventually, that millimeters of mercury became an equivalency of 1 torr based upon the Torricelli barometer from the Italian scientist. And then from that equivalency, since the first barometers measured atmospheric pressure, there was a standard height of millimeters of mercury used to express atmospheric pressure, which led to this third unit, atmospheres, ATM. And so by definition, 1 atmosphere was equal to 760 millimeters of mercury. So from the barometer, we get these 3 different units that are used to express pressure. What we generally use in the lab, and what you guys will hopefully use in lab when we do the aluminum analysis experiment, you're going to be generating a gas in that experiment, and you're going to be determining pressure by using something that is similar to a barometer, but it's called a manometer. And what distinguishes a manometer from a barometer is that you measure the pressure of a particular substance, generally a gas that is enclosed in a substance, by measuring the difference in pressure between the gas and atmospheric pressure. And that difference is determined by the height of a column of mercury or of water between the 2 arms of a manometer. So you guys will use, hopefully, when I'm recording this, our building is closed, but hopefully you guys will have experience in using a manometer for the aluminum analysis lab later in the semester. But both a barometer and a manometer are used to measure the pressure exhibited by a gas. And the take-home message, which is also the last slide for my little video, this little vignette, is that pressure is measured in primarily 3 units, atmosphere, millimeters of mercury, and torr. You need to memorize those equivalencies when doing pressure calculations and gas law calculations in this unit. Now, there are other equivalencies, other units of pressure that you have probably heard about, like PSI or pascals or bar. I have those equivalencies listed here. You do not need to memorize those. If you do need to use them in a problem, I'll give them to you. But you should know how to use those equivalencies to do conversions if needed. The three that you need to measure is between atmospheres of mercury, or between atmospheres, millimeters of mercury, and torr, that blue star. So that's the end of this little vignette. In the next video and in subsequent videos, we will start to talk about individual gas laws, mathematical expressions that can describe a gas sample's pressure, volume, temperature, and amount, specifically moles.